Okay, so let's start with the schedule then. So first I'm going to go over some homework problems, just to go over the homework problems. So most of the people that have turned in the homework, which is quite a lot, which is pretty good, have gotten like 3 out of 3, 2 out of 3, which is very good. But I'm just going to go over the homework questions until, unless some people don't know how to do them. And then we're going to go over quadratics and some new stuff about them, then some additional solving techniques, and that's going to be our lesson for today. Okay, so let's go with the homework. All right, also, I'll give everybody a couple minutes to put your answers in the homework in the chat here. Yes, William, you're raising your hand.
I was raising my hand to answer the question.
Oh, that's fine. Okay, I'll give everybody like a couple minutes to answer this question. Okay, and then we can go over it. Okay, so let's see. All right, so William says -1 plus or minus the square root of 10 over 5. So let's look at that. Okay, so William, can you explain how you did this?
Okay, so first, I multiplied the equation, both like every single term by x plus 1 times x plus 2. So that is equal to 2x plus 2 plus 2 times x plus 2 plus 3 times x plus 1 and which is equal to 5 times x plus 1 times x plus 2. So now, so this equals, so if we simplify factor out the term on the right, then it will be equal to 2x plus 2 2 times x plus 2 plus 3 times x plus 1 equals to 5 times x to the power of 2 plus 15x plus 10. So then we also factor out the thing on the left. So that is 4x plus
You mean
4. 5. Oh yeah, 5x plus 7. So then that means 5x to the power 2 plus 10x plus 3 is equal to 0. And then I just did the quadratic formula because factoring it out doesn't work. So yeah, so then -10 plus minus the square root of 100 minus 60 over 10, and that is equal to negative 10, negative 1, and then plus minus um the square root of 40 over 10. Uh, yeah, and and then after that, that will basically equal to negative 1 plus minus 10 over the root 10 over 5.
All right.
So
Very good. Very
yeah.
good. So you use the quadratic formula. Yes, that is, I think that's the best method here since you can't factor it anyway. So very good job. Okay, now let's go on to the second one. Here's the absolute value inequality. So let's see how you guys did on that. All right, so I'll give you a few moments to put your answers in the chat, and then we can start doing some stuff. All right, so let's go over this one. Let's see what we have here. So -1/2 to 3/2. That's what most people got that turned in their homework. So let's see who wants to answer this. Okay. Evan, would you like to answer this? Okay, if not, then who wants to volunteer to answer this one? Okay. How about Kaylee? Can you answer this question?
Okay. So first you add 1 to both sides.
Okay.
And then it's 4x minus 2 is less than 4. And 4x minus 2 is greater than -4. Then we add 2 to both sides. And then we divide by 4. So it should be -1/2 and 3/2.
All right. Very good. Okay. So let's do this last one then. Okay. Okay, so now let's do this one. So let's see our answers here. Evan says, yes, okay, that is the definition of the absolute value. Okay, so now let's try this one then. Okay, so let's see here. What we need to do is we need to move this to the other side, first of all. Okay, so let's just do that. X plus 1's absolute value of x plus 1 is equal to 5x plus 1. And then, you know the definition of absolute value here. So what we can do is we can remove the absolute value and make it to plus or minus 5x plus 1. Then you're going to get two scenarios. You're going to get x plus 1 is equal to 5x plus 1. Or you're going to get x plus 1 is equal to negative 5x minus 1. And then you can just easily solve for these scenarios. So let's just do that. X here is going to be 5x. Then as you can see, x is equal to 0. And then from this one, you can see that x is going to be equal to negative 5x minus 2. And then you get 6x is equal to negative 2, and then x is equal to negative 1/3. But if you plug negative 1/3 in to this equation, you can see that it doesn't actually work. So the only answer is going to be x is equal to 0. All right, are there any questions on this? If there are no questions, then I am going to lecture for today. So let's go to quadratics. So quadratics, the standard form of quadratics is going to be, of course, ax squared plus bx plus c is equal to 0. We all know that quadratic form, right? So let's see here. I wanted to give a couple examples on how to solve the quadratics. But before that, I want to review on how to factor. Okay, so let's go to the next slide on how to factor. So we all know how to factor, like where an expression where a is equal to 1, right? X squared plus like 5x plus 4. You all know that. Well, what we need to do to factor this is we need to find two factors of 4 that add up to 5. And it's just 1 and 4, so it's just x plus 1 times x plus 4. That's how we factor something like that. But when we have a that is not equal to 1, we have a is equal to 3, then we're going to have to approach it a different way. So let me explain it this way. So what you can do is you can take this a term. From here, let's just list out a, b, and c terms from this definition of this form. Our a term is going to be 3, the b term is going to be 7, and the c term is going to be negative 20. So to factor this, first we need to list all the factors of a. So these are the factors of a, and these are factors of c. We're not going to worry about b yet, because all of these are going to add up to b. So we're going to find two factors of a, let's say 1 and 3, and two factors of c, let's say like negative 4 and 5, such that they add up to b, such that when they're crossed like this, they add up to b. But it doesn't work right now. So if you have 1 and 3 and negative 4 and 5, as you can see, if you cross these like this, 1 times 5 plus negative 4 times 3, we can see that it's actually negative 7. So it doesn't work. It doesn't add up to b. But we can switch it around a little bit and move the negative to the 5. So now we have 4 and negative 5. And as you can see here, if you cross them, negative 5 plus 12 is going to be equal to b, equal to 7. right? And then once you confirmed that these factors of a and c when crossed is equal to b, the b term, then what we're going to do is just go straight across here. 1 and 4, that's just going to be x plus 4. And you're going to go straight across here. 3 and 5, it's going to be 3x minus 5. Right? So once you confirm your factors, then you can just factor it like so. And then that's going to be equal to 0. Okay? And you find out that x is equal to -4 and 5/3. Okay, so that's how you factor it and solve with factoring. That's the method that I recommend we do. Always factor if you can, right? Because it's the fastest. If you do like the quadratic formula, it's going to be pretty slow, especially when you have big numbers and you have to like add them all up, and you might even make mistakes. So it's not good. But in this case, we can try the quadratic formula and we'll get the same exact answers. So the quadratic formula is, well, like negative v plus minus square root of b squared minus 4ac over 2a. So we all learned this in basic algebra, right? We learned this formula in basic algebra, and I'll prove it today too. Prove the quadratic formula, it's not that hard. Okay, so negative b is going to be -7 plus or minus the square root of b squared, 49, plus 240. Okay, pretty sure. So AC is going to be -20 times 3, so it's -60 times 4 is going to be -240, but then you're subtracting it, so you're basically adding it back. So the square root of 289, I'm pretty sure is like something 289. I think it's 17 or something. Square root of 289. Yeah, it's 17. Okay. So then as 2a is just 6, okay, then you get -7 plus or minus 17 over 6. You get either, if you have -7 plus 17 over 6, you're going to get a 10 over 6, so it's just going to be 5/3, or you're going to get -4. Okay, so we get the same answer, right? Same answer. Very good. Are there any questions on this particular section? I don't think there should be, because we have already covered this a lot in basic algebra. So now let's move on to something that we haven't covered that much. So we did cover a little bit about completing the square, but usually in school, they don't teach you completing the square in Algebra 1. So in Algebra 2, that's where completing the square is more widely used, both in factoring and in other applications. So let's learn how to complete the square. So let's just first observe a pattern. So x squared plus 2x plus 1 is equal to x plus 1. So a lot of you who have done a lot of math should know this, right? This is a square term, right? X squared plus 2x plus 1 is equal to x plus 1 squared. You can multiply it back out and see, right? Now, if you have x squared plus, like, let's say like 4x plus 4, that's going to be equal to x plus 2 squared. And we refer to these as just perfect squares, right? With involving the variable. So x squared plus 6x plus 9 here is going to be equal to x plus 3 squared. So let's do this last one. X squared plus 8x plus 16 is equal to x plus 4 squared. So from here we can observe a pattern, right? Let's observe a pattern. So what is 1? 1 is the c term. And you noticed that in each of these perfect squares, the c term is going to be exactly half of the b term squared. So 1 is equal to 2 over 2 squared. And you see here 4 is going to be 4 divided by 2 squared. So in each of these, the c term, like in x plus 3 squared, the c term is 9, and that's going to be 6 over 2 squared, 3 squared, right? And from this, we can see to complete a square, if we've already have the x squared and the x terms, to complete the constant term, all we need to do is we need to take this b term, divide it by 2 and square it. So basically, essentially, we're adding the constant b over 2 squared to both sides, right? So to solve this, let's just do that. But before we do that, let's move the 2 here on the other side so it doesn't mess us up. So x squared plus 6x is equal to 2, right? So the square we're trying to obtain is going to be x squared plus 6x plus 9 here, trying to obtain the square. Okay, so what we actually need to do is you have to add b over 2 squared. What is b? B is 6 in this case. So 6 over 2 is 3. And the 3 squared is 9. So we're just adding 9 to both sides. X squared plus 6x plus 9 is equal to 11. Okay, then you can get that we can just factor this. X plus 3 squared is equal to 11. Now this looks a lot less complicated. This is so much more easier because you can just take the square root of both sides. Okay, remember that the square root of x squared is equal to the absolute value of x. So therefore, x plus 3 must be equal to plus or minus 11. Then therefore, x is equal to negative 3 plus or minus 11, right? Well, square root of 11. Square root of 11, right? So not this one, not this one. This is just 11. Okay, so after you square root, you have to square root both sides like so, and then you get that. Okay, so completing the square is really efficient sometimes. You might even choose it over factoring sometimes. But again, factoring usually the best method, but you can complete the square once in a while. Okay, now let's try additional solving techniques. Okay, so before we do all of that, let me just prove the quadratic formula. So let's see here. Let's erase all of this. But the answer, what is the answer? X. Answer this is x is equal to negative 3 plus or minus square root of 11. Now we have a lot of space, right, to prove the quadratic formula. Proof of quadratic formula. Okay, so we know that the general form is ax squared plus bx plus c is equal to 0. So before we just use this formula. Before we just use this formula without knowing why it's true, right? It's a magical formula. It tells you the answer straight away. Okay, so but why does this actually work? And this sometimes in algebra 2, the proofs are so complicated because you have to use calculus, because in algebra 2 the theorems become more and more complex and sometimes you can't prove it. But now let's just prove this one because this one is easy to prove. To prove this one, all we need to do is actually just complete the square. So if you haven't noticed, if you want to complete the square, the a term must be equal to 1. In every one of these, the a term is equal to 1. So to make sure, to absolutely just make sure that the a term is equal to 1, what we're going to do is we're just going to divide by a on everything. Right? X squared plus b over a, x plus c over a is equal to 0. Okay? Just making sure that the a term is equal to 1, that we just have an x squared here. And just like we did in this problem, we're going to move this somehow like negative 2. We're going to move negative 2 to the other side, except this time it's c over a. So x squared plus b over ax is equal to negative c over a. Now we can actually try to complete the square. So remember how I said we're going to add the constant b over 2 squared on both sides, right? Okay. And what is the b term here? The b term here is b over a. So then b over 2 is going to be b over 2a, and squared is going to be b squared over 4, b squared over 4a. Okay. So essentially, we're just adding all that. B over 2a squared is equal to negative c over a plus b squared over 4a squared. Okay. So after we've done that, we can actually just factor this into a perfect square. This is going to be x plus b over 2a squared, like that. Okay? And then, while we're at it, let's just simplify the other side. Let's say this is a negative b squared minus 4ac over 4a squared, right? But then we take the square root. When we take the square root, we get x plus b over 2a. Don't forget, there's a plus minus here. It's the square root of b squared minus 4ac over 2a. Don't forget the plus or minus. And then simply, we just get x is equal to negative b plus minus square root of b squared minus 4ac over 2a. So that's how you prove the quadratic formula. You might not think it's very complicated, but it's really not that complicated. You just complete the square in its general form. You just use that general form and you complete the square, right? And then you get this identity. A very useful formula. Okay. Are there any questions on this? Yes, William.
So how did the plus minus sign get there?
It's because remember, when you square root x squared, you get absolute value of x, and therefore x is equal to plus or minus something, right?
Okay. Thanks.
All right. So think about like x squared is equal to 16. First, you gotta just square root both sides, right? Then x is equal to plus or minus 4. You know this, right? Because the difference in squares, you can try and do that. You know that x is equal to plus or minus 4. So how does that get there? It's because when you take the square root of x squared, it's going to be absolute value of x. And then it's just plus or minus 4, right? Okay, so that's how the plus or minus gets there. Now let's go on to additional solving techniques. So we've done a lot of standard stuff, but here we're going to see some not so standard stuff. So x minus 5 is equal to square root of x minus 3 with some square roots involved and some more square roots. And number 2, we're going to learn about how to do that. And then this, that's x to the 4th, right? We don't know how to do that yet, right? Later on, we'll know how to do this by factoring and all of that rational roots, but right now we don't know. So how are we going to solve it, right? And then we have this ugly little equation thing, right? With x to the power of negative 2 over 5, right? That looks very, very complex, right? You're going to probably get a very complex number and it's not going to be very good. So we're going to learn about how to solve these with these very clever solving techniques, okay? So let's just, this first one really isn't that hard, right? We're just going to classify it as an additional solving technique because you don't see it that often. So everybody just do this first one, right? Just do this first one and see how it goes. Okay, so this one is very, very easy, actually, if you think about it. All you need to do is just square both sides, right? Just square both sides. And that's my hint to you. I'll give you a few moments to try and solve this. Once you square both sides, it's really easy. You just solve it like a quadratic, right? Okay, and I'll give you a couple moments to solve everything. And then put your answers in the chat and we can go over it. All right, so let's see. Do we have answers? X is equal to 4 or 7, and William says, you said previously, X is equal to 7, 4, and you didn't like the X is equal to 4, so you only said X is equal to 7, and that's actually the correct answer. Very good. So remember to check. That's one of the key things about this, is that you need to remember to check your answer every time, right? So let's see how we do this. Okay, so right, you just square both sides. X minus 5 squared is equal to X minus 3. Okay, then you get X squared minus like 10X plus 25, right? Minus X plus 3 is equal to 0. X squared minus 11X plus 27. And I don't know, can you factor this? It seems like, yes?
I got plus 28.
Oh yeah, that's true. That's dumb. Okay. Bad mistake. Okay. Then you can factor X plus this. Yeah. Then you can factor and you get X is equal to 7 or 4. But if you actually check this, if you check this answer, you're going to get, when you check X is equal to 4, you're going to get like -1 is equal to 1, which is not correct. So this is a bad answer, and you only get X equal to 7. So the key point here is to check. And for this next one, we're still going to check. We're still going to check here. Okay. So let's see what we need to do. So, how about this? I'll give you guys a little bit of time to try and solve this on your own. And then if you don't know, then we're going to walk through it. So I'm going to give a couple of moments for you guys to try to solve this, right? See if you can solve this. Okay. So let's do this then. Okay, so this one is little bit harder. All right, so let's actually, the first thing we actually need to do is we need to move this square root to this side, because we don't want two square roots on the same side. So that way, when we actually like square both sides, it's going to be very complicated. So let's just have one square root on this side, and when we square both sides, this square root is going to go away. So we're going to have 5 minus x plus 2 here, and then we square both sides. Okay. Now, what we can do is, let's say, we can square both sides now. So, this is going to be equal to 25 minus, like, what? 10 square root of x plus 2 plus x plus 2. Okay, here. Then when you square this one, this should equal to 2x plus 5. Okay, now following this same strategy, can you guys now try to solve this? Okay, so I'll give you guys a little bit more time to now try and solve this way. Okay, so follow my same technique. Okay, so move everything to the other side and square both sides. Now you should probably be able to solve it, right? So let's see if you guys can solve it now. Okay, now we can solve it. Okay, so right. So we look at this. We're going to get well, let's move everything to the other side then. Let's just subtract 25 from here. Subtract the x and the 2. So we're going to get 2x minus 20 minus x minus 2 is going to be equal to negative 10 square root of x plus 2. All right. Then what we can do is we can continue to x. This is x minus 22 is equal to the same thing, to negative 10 to this. Okay. And then if you square both sides, okay, square both sides, x minus 22. Okay, squared. And then that's equal to 100 times x plus 2. Okay, then you get this very big thing. Okay, but after you simplify, it's actually not that bad. But we're running out of time. But this is pretty easy to do, and always remember to check again. So let's just do the last few. Okay. I'm just going to do these last ones. So, okay. So for this one is quite clever. What you need to do is you actually need to set u is equal to x squared. If you set u is equal to x squared, then you get u squared plus 3u minus 4 is equal to 0. Then you just solve for u and then solve for x, right? So what is this? Yeah, I actually have to, no, this is, yeah, that's a 4. So then u minus 1, u plus 4 is equal to 0. And substitute x squared for u. Then x squared minus 1, x squared plus 4 equals 0. Okay? Then you're going to get this, obviously, x is equal to plus or minus 1. But this one is undefined. When it's equal to 0, you can't find x because you're going to have the square root of negative number. We're going to learn about imaginary numbers and the square root of negative numbers next class when we learn about complex numbers. But right now, when you get one of these, just say no solutions for the rest of them. The only real solutions are plus or minus 1. For this one, we can actually do. Okay, and all you need to do is you're going to set u is equal to negative 1/5, x to the negative 1/5 actually. So then what you can do is u squared is just going to be equal to x to the negative 2/5. Okay, then you get 3u squared minus u minus 2 is equal to 0. Okay, so I've given you that many hints. So I like you guys to try to do this one, okay? From the same technique that I showed earlier. To try to do this one. Okay, same technique. And once you get u, just find x from u. Okay, so let's solve this one then. What we need to do is we're going to have to solve this quadratic. I'm pretty sure you can factor this somehow. 1, 3, negative 1, 2. Yeah, that does it. That's u minus 1 and 3u plus 2 equal to 0. U is equal to 1 and u is equal to negative 2/3. Then you find x from it. Well, x is equal to negative 1/5 of u, which in this case is 1. So from that, we're going to get, let's say here we have basically, we want to reverse this 1/5. Basically, we're going to have what? 1 over the 5th root of x is equal to 1. And if we multiply this, then we're going to have 1 is equal to the 5th root of x. Oh, not really, is it? Actually, if we have here, hold on. So let me think about this for a second. Let's see on how I don't want to do this with logarithms. So let me review this, how we could do this. So if we want to do this, hold up a second. Ah, yes, okay, here we go. We're just going to get x is equal to 1 here if we unravel it. It's just x is equal to 1. Okay, so there was no complication about that. Stupid mistake. Okay, then we get the next one. Let's see here. We're going to get 5, the 5th root of x, going to be equal to -3 over 2 because we take the reciprocal of that, right? And then we get x is equal to just this to the 5th, right? So it's very big actually. We get something like this. So that's how we solve that, right? After we find u, we're going to find x. Sometimes a little bit complicated like this. Sometimes not as complicated, right? So today, that's all we're going to do today. Okay, so we cover quadratics and some additional solving techniques. Okay, are there any further questions on this then? Any further questions on this? If there are no further questions, then that's all for I have today. Okay, thank you for listening, and I'll see you next week. Okay.